Hello, everybody. This is Georgia, and we're in week 5. Today, we are going to talk about correlations and much more. So, let's go ahead and cover what are the main key points of this lecture. First of all, what I really want you to get out of this is what is a correlation and how to interpret the value of the correlation. I don't want you to know how to manually calculate the correlation coefficient. If you go to your book on page 85, you're going to see this very, very long, scary formula. Not to worry about it. Look over it, try to understand it. But for the most part, when the time comes, we are going to use SPSS. So please do not get intimidated. If you don't want to read it, you may skip. But what I really, really want you to get from this chapter is to understand what the correlation is and how, if you see an actual correlation coefficient number, to know if that is a strong or a weak or a moderate correlation. Okay, nothing more than that. So, who is the creator of the coefficient correlation? Mr. Carl Pearson, a British, very, very wealthy man from a very aristocratic background. In fact, he spent his entire life studying different things that seemed interesting to him. He studied law, he studied biology, mathematics, statistics. He was a very curious mind, but of course, he never really had to work in his life, so he had, I guess, the luxury to just pursue whatever he found interesting. Now, what's interesting about Carl Pearsons, we cannot decline the fact that he was a brilliant man. Nevertheless, he was one of those people that belonged to the eugenicist category, and pretty much what he believed or what he saw was that he saw a war against inferior races, and he thought that that was a logical implication of his scientific word. In other words, he kind of like said that nations is wasting money when it tries to improve people who come from very poor stock. In other words, that if you're poor, you're stupid, and the reason that you're stupid is because you're poor. Now, to give a little bit of credit, when he did the correlation coefficient, it was thought in terms of causation and not in terms of correlation. Now, today we know that just something because something shows an association or a correlation that does not necessarily translate to a causation. So we deserve to give him a little bit of credit because back then they didn't exactly figure out the whole thing. But nevertheless, he was a very, very brilliant man, and he was the founder of the Pearson product moment correlation coefficient. So, what is a correlation? A correlation basically studies the relationship between two variables. So since we're having two variables, we're going to call it a bivariate correlation. Okay? So bivariate means two variables. In terms of how we express that relationship is going to be with numbers that range between -1 and +1. 0 would be no correlation whatsoever. -1 or +1, they're going to be very strong correlations. Now, I want you to pay attention here that the sign does not matter, okay? People tend to think the negative numbers as being lesser, okay? Now, what I want you to think of it here as a direct or indirect kind of a relationship and not necessarily just because it's negative, it's less important, less strong, okay? So I want you to be focusing is in the absolute value of the number, okay? And just the negative or the positive sign simply shows direction. Now, what do the different numbers mean? Okay, so if you see anything from point A to point 1, that means you have an extremely very strong relationship. Kind of rare, especially in the humanities field, okay? But boy, if you get a point 0.8 and above, that's incredible. 1, I would say, is very close to impossible, but it would be great if you have it. Uh, the majority of times you're going to have anything in the middle here between point 0.2 and point 0.8, okay? So every time that you're trying to associate things, you're going to find either weak relationships, moderate, or strong. And of course, there are times that you're going to find no relationship whatsoever. So anything from 0 to -2 is going to be very weak to almost no relationship at all. Point 0.2 to point 0.4, it's going to be a weak relationship. zero point 0.4 to zero point 0.6, it's going to be a moderate relationship. To be honest with you, if you have anything zero point 0.5 and above, as a researcher, you should be pretty happy because it means that you got something there. Now let's talk about direction. What does it mean to have a positive or a negative correlation? In a positive correlation or direct, that's another way of saying positive, simply because positive can be confusing. Okay, so direct is another term that means exactly the same thing. And what it really is when you have two variables that they're moving towards the same direction. So usually you're going to have variable x, right? Let's just say that x is signifies weight and y signifies height, okay? So you would assume that people who are taller would be heavier as well, right? Because they have more room to gain weight, if you want to think it in these terms, but it's not always true. Nevertheless, right, you most likely you're going to find a positive association between height and weight, because as the height goes up, the weight should go up as well. So as you can see here, it doesn't matter in what direction it goes, okay? It can move towards positive or negative direction, okay? As long as they move towards the same direction, that is going to be a direct relationship, okay? Now, an indirect or negative relationship, it's going to be when your x and y are moving towards the opposite directions. So in this case, let's bring the exercise and weight example. Let's just say that x represents exercise and y represents your weight. So normally, the more you exercise, you would think that you would lose weight, right? So as the one variable goes up, the other one we should go down. So that would be an indirect or negative correlation. Now, when you're solving correlations, you need numbers, okay? So there's no way you can ever solve a Pearson's correlation for nominal or ordinal variables. Most of the times you're going to have continuous type of variable, so it has to be either interval or ratio. Okay, anything else will not work. Now, in case of categorical and ordinal kind of variables, there are other tests out there. I don't want you to worry about that right now, and even your book mentions a few of them. I'm not going to test you. That's actually part of advanced statistics, but just know that there are other tests that they're being used anytime that we want to study correlation between two variables that are not measured at a continuous level. Okay. Now let's see an example. I don't know if you remember the song Gangnam Style. Okay, I remember a few years back, every single store, department store, bar, everywhere you went, the Gangnam Style was playing. Okay, so if we had to plot that out, right, we would see a very high positive correlation, right? Because the more places that you went out, the more likely you were going to hear that song, right? So as you can see, that would be a fairly strong correlation. Now, a perfect strong positive correlation looks like this in your right here. It's going to be a perfect line. As I said before, kind of impossible, but nevertheless, that's how it looks. So the idea of a perfect one positive correlation, or even if it's a perfect negative, would look like going like this way. It has to be on a straight line. That means that all the points correlate with something on the y. So every x point here correlates with a point on the y-axis, and that's why it forms a perfect straight line. Now, when not all points correlate with each other, they're going to be like spotted like that. So you're going to have a scatter plot. And what you're trying to look here is how closely those dots are. The closer they are together, and the more you will be able to see that they try to form a straight line. That means the stronger your relationship will be. If it's scattered all over the place, that means probably you do not have any correlation whatsoever. So in the case of Gangnam Style, this is what we would see today, right? We wouldn't see much of a correlation. We would probably see even a very weak negative correlation simply because people got sick of it, right? You heard the song so much and, now it's not cool to play that song anymore. So let's interpret some numbers here and expect to see something like that probably in your upcoming midterm. So I might give you numbers and you need to identify if that is a weak or a moderate or a strong correlation and also identify the direction. So in the first case right here, you have an R equals to 0.24. Pay attention to where the decimal point is, okay? So 0.24, apparently, there's no negative here, so that is a positive. But because it's zero point 0.2, makes it a weak positive or a direct correlation, okay? This one has a negative, so I know it's going to be an indirect or a negative correlation, and it's 0.56. Remember, we said anything from zero point 0.4, right, to zero point 0.6, it's going to be a moderate correlation. 1. Here, pay attention to the 1 and not the negative. A lot of you will see the 1 and say, oh, it's a negative number, so that's small. It's less than 0. No, what I want you to see is the absolute value here. So you're taking the 1 and then you're seeing the direction. So this is going to be a very strong indirect correlation. Here, pay attention to the point. Do not see this as a 1 because it's not a 1. It's a 0.1. So this is an extremely weak positive correlation. And finally, the 0.78, that is a strong positive or direct correlation. Now, this is the scary formula that I told you about. Do not get intimidated. You do not have to memorize it. You do not have to solve any manual. I mean, if you want, just go look at your book, go over it. All it says here is that R, this is Pearson's correlation. Actually, this is the symbol, a lowercase r, okay, equals to n, that's your sample size, the summation of the product of x times y minus the summation of all the x values times the summation of all y values over the square root of n, which is your sample size, times the summation of your all x values squared minus all the summation of x values, but then square that sum, okay? And you do the same thing for the y, okay? So although it looks complicated, it's not really. It's just a little bit of a pain to set it up. So usually what we do, and if you look at your book, you're going to set up like a table, and then you simply lay out all your x and y values, and then you square them and you sum them. This way you like kind of like select what you want and you plug it into the formula. Now, SPSS does a fantastic job. It's literally 2 clicks. So we're going to stick with SPSS for the most part. Hip to be square, the coefficient of determination. That is another very important concept that you need to understand. It's a little bit out there, but bear with me and I think you'll get it. Now, coefficient of determination, it simply is the square of the Pearson's correlation, moment product. But what it really means and what it really describes, and that's the definition of what I'm going to say here, is that it describes the amount of variance which can be accounted for by the variance in another variable. What do we mean by that? That means that if you're having two variables that they share a very strong association, that means whatever varies on variable x, it will vary on variable y. So that shared variance, right? If you square, that means you're going to see the true value of the components that they have in common, okay? And what's left is going to be what is called the coefficient of alienation. It's in your book on page 93. I highly recommend that you go over it and you understand what's going on with those two concepts. But let's see an example. So let's see the association between pizza and happiness. Most people love pizza, and hopefully when you love something, it makes you a little bit happier than what you were before. So let's just say we gave a bunch of people to a pizza to eat, and then we asked them how do they feel, okay? And we had some kind of a scale that we measured their happiness levels. And we plug in those numbers, and we get an R of equals to 0.96. Now, according to a formula, in order to calculate the coefficient of determination, we're going to take our R and we're going to square it. So if our R was 0.96 squared, that means that our coefficient of determination is going to be equal to 0.92. Mighty strong indeed. What does that mean? That means that 92% of the variance in happiness can be explained by the variance in pizza intake, okay? It doesn't necessarily mean that pizza is what makes people happy, but it means that there's some kind of an association that for whatever reason, people, when they consume pizza, it may affect their mood some way. Okay, it is not necessarily as a causation for, increased levels of happiness. Otherwise, everybody would be eating pizza. Now, what's left off from 92 to reach 100 in order to be 100% have that strong association? That means you have 8% missing. So what is missing there? That's going to be the coefficient of alienation, and that is the amount or the percent that cannot be explained by that association. If you were to see this uh, in a graph form, let's just say that the red circle underneath here is going to be pizza consumption. The blue circle would be levels of happiness, and 0.92 is going to be what those two variables share together. Okay, so what is left over is going to be that 8% that cannot be explained. Okay, so there's an association there, but it cannot be explained by the association of the two variables that we just correlated. Now, what do you do if you have more than two variables? You build what is called a correlation matrix. Hence, I put here the little picture of the Matrix movie so you can remember it. This is how it looks like. So you build a table. It looks like a cross tabulation table. So you're setting up your variables, okay, vertically and horizontally. And pretty much what you do is you solving a bunch of little bivariate correlations. So if you ever correlate any variable with itself, you're always going to get a perfect correlation because, as you can imagine, as you know, they will vary exactly the same way, so you're always going to get a perfect one. So anything that correlates with itself, it always going to have a perfect one here. So you see vote with vote, always perfect one. Attitude with attitude. Now here we have the income and education. So does income affects education? Well, we can see here. I mean, these are all hypothetical examples, okay, those numbers. So income and education, you get a Pearson's correlation of 0.574. So that is a moderate, indeed, correlation. Now, does income affect your attitude? Not really. This is an extremely weak indirect correlation. And does income affect how you vote? Not really as well. So this is a very weak relationship, barely touching moderate. So in the negative direction as well, indirect. So there's not much here as well. Okay, so the only strong correlations that we would have here would be the income and education. Everything else to me looks mighty weak. Okay. What I want you to remember is that correlation does not equal causation. We will talk about this concept again at a later chapter. This example was taken straight out of from your book, and probably it's a very simple, funny example to understand what we're talking about. So try to imagine this scenario. So you have a local police officer that observes that as ice cream consumption goes up, so does the crime in the city. Okay? He measures both and he finds a direct positive relationship. So as ice cream consumption goes up, so does the crime. Luckily, the police officer, right, he recalled what he learned when he took his stats class. But Joe Bob, the local commissioner, he skipped stats, so he had no idea, okay, that correlation does not necessarily equal causation. So what do you think? There's definitely a positive correlation that we see, okay, so as ice cream goes up, so does crime, but does that necessarily mean that ice cream causes people to commit more crime? Well, most likely no, I would hope not. Okay, so what are some of other things that can relate to both? What other variables can have interacted, okay, that could have caused crime to go up as ice cream went up as well? Well, let's think. Summer, you got longer days. That means you have more time, better daylight, right, for thieves to go around and break into the houses and steal and get what they need to get. Also, during the summer, right, it gets really hot and people want to cool themselves off, so they're gonna eat more ice cream, right? and probably they're going to be going out to be eating that ice cream, so more likely they're going to be leaving their homes open. So as you can see, there's other variables that can interact and give you the results that you're giving you. So that is why scientists know that any time that they get a very high positive or negative correlation coefficient, it doesn't necessarily means that the one caused the other to happen. There might be other variables that interact, and we have to always take that into account. So good job, everybody. This was our lecture for today. Now, I just want to say one thing about your next chapter that you have to read, the reliability and validity. That chapter is purely theoretical. So I'm not going to give you a recorded lecture for that. I gave you a PowerPoint. So go ahead and read your PowerPoint because it's more, I've kind of tried to like make it a little bit more concise than what your book is. But then if you don't understand what I have on my slides, go ahead and read your book, okay? So there are going to be quite a few theoretical questions. There's not much there to explain. It's just a matter of reading it and memorizing a few concepts. All right? Have a good one.